Hi everyone, I'm Angie Kellen for SID. Today we're in San Francisco, California for Display Week 2016. I'm on the show floor at the Moscone Center, and joining me right now is Ron Zohar. He is with My Polymers, and we're here because they won a Best in Show for the small exhibit category. Congratulations, Ron.
Thank you, Angie.
So let's talk about the company a little bit, about My Polymers.
Okay. We specialize in low refractive index materials. Our roots historically are in the photonics industry, and we have been supplying low index coating materials for the photonics industry, specifically for specialty optical fibers, for quite some time now. Our polymers, or our specialty, as I mentioned, is in low index materials. To demonstrate the type of materials we have this display right here, where you can see some fish made out of our polymer. Due to the low index of 1.33, which matches water, the fish disappears when it is submerged in water. Just for reference, we have another fish here made of a polymer with a higher refractive index of 1.5, and you can see that as the fish made of our low index polymer disappears, the other remains clearly visible. You have another pair right here. So we've been supplying this kind of materials into the photonics industry for quite some time now. And they have their own advantages for this industry, and still we have been trying or attempting to go with these materials into bigger markets, namely or specifically into the display industry. But we found out that this type of materials, they had a disadvantage in that the adhesion is relatively low, or too low for the demands of the display industry. So we've been actually, Ehud, our CTO, and his team have been working on it for years now. And last year we had our own small breakthrough when we managed to develop an optical, a low index optical adhesive with significantly a stronger adhesion. And this is the adhesive with which we came for this show, and you can see a demo right here just to demonstrate the strengths. So the refractive index here is the same as these adhesives, but the adhesion is roughly 2 orders of magnitude higher, like roughly 100 times higher. And this qualifies this low index adhesive for uses in the display industry. We could try to hang even a 10 kilogram weight. We just didn't want to carry it with us all the way from Israel.
I don't blame
that's
you.
where we are located. And so just to show, I mean, probably won't show very clearly, but the field force is really strong, which is the most challenging test in adhesion. So, and in terms of applications, what we are seeing now is various possible applications. One application is in thin LCDs, TVs. If you want to bond the adjacent layers to the light guide, such as bonding the diffuser film or the reflector film into the light guide. We see some applications in virtual reality, augmented reality, as we see here. Even say in the field of the evolving field of flexible displays or curved LCD displays, a problem which is now facing manufacturer is the light there is a problem of light leakage out of the displays. So we believe, or we think, or hope, using this type of adhesive can minimize light leakage in these applications. We even saw some possibility to use this material in autostereoscopic displays, because the bigger difference in refractive index enables a bigger difference in disparity. And just to add a few more, we also see some interest in building the low index grid in OLED displays, and last but not least in transparent, non-ITO transparent conductors, such as nanowire based conductors. So this is regarding the applications that we currently see in this field. Some background about the technical issues involved in developing these adhesives will be given by our CTO, Ehud Shori.
Terrific.
Okay.
We're back with Ehud, who's going to provide us a little bit more of a technical explanation.
Hi. In the short history of my polymers, there are two breakthrough events that happened. One was the development of low refractive index polymer, reaching down as low as 1.30, which is probably the limit that polymer chemistry can reach. Until that time, only PTFE, which are like Teflon type of polymers, could reach that low level, but they cannot be processed as a liquid and they are not useful as adhesives. So the first breakthrough was to develop low refractive index resins. At the beginning, as Ron said, they were poor in adhesion properties, but still useful for optical fiber industry and like that. The second, more recent achievement was the development of a polymer with the same very low refractive index of 1.33, again matching that of the index of water, but with as Ron mentioned, much stronger adhesion. All this was being able by using fluoropolymers. And fluorine is the only chemical element that can reach down below an index of 1.40. Even the magnesium fluoride, which is used to coat our glasses, has a fluorine in it. So fluorine is the only element that can be used. So ours are fluoropolymers. The problem with fluoropolymers is the adhesion. They are known to be non-adhesive. So achieving the ability to have such a strong lamination adhesive, this is the real breakthrough that we came through. And this is why we are here, and we are very proud to be here, very proud to get the award. This is about it.
It's terrific. Well, thank you for taking the time to explain all of that, and there are many, many applications for this, so it's no wonder you did win the award, and congratulations on your breakthrough. We look forward to seeing you next year, hopefully.
Hopefully.
How has the show been for you?
Oh, very interesting. It was really exciting. Yeah.
Have you had a lot of people coming by?
Many people coming by, and we went around and found a few very interesting ideas and probably way of cooperating with other technologies. Yes, it was very interesting.
Well, terrific. That's what Display Week's all about. Well, congratulations again, and like I said, we hope to see you next year.
Thank you very much.
In San Francisco, Angie Kellen for SID.